It's been said to me by professors even of conservation that we know more about ancient Egypt than we do about film post-production of the 1920s. We're still at the beginnings of this enterprise because of the complexity of the collections that we have. I think this is a generational opportunity and it represents something of a world first. So our latest research infrastructure program is one that I'm really excited about. We are building right now a moving image conservation research laboratory, and that will be based at the Conservation Centre, but it will be a facility that will be open to researchers in order to come and study moving image objects, film, videotape, related collections like posters and press books and scripts and other objects. And it's a sort of facility that you might find in the world's largest galleries and museums, at the British Museum, at the Rijksmuseum. This research lab will be established so that we could analyse various kinds of objects, anything that you will find in the BFI National Archive collections, and potentially, of course, other moving image collections around the world. We expect it to be a really collaborative space and facility that will be heavily in demand, because this is the kind of research, physical research as it were, that hasn't been done previously. So this new lab that we're building is part of a programme from the Arts and Humanities Research Council. It's a huge £80 million investment in UK heritage science, not just film and television, but all aspects of heritage science in the UK. And the programme is called RICHES. That's Research Infrastructure for Conservation and Heritage Science. And to have moving image represented and to have it hosted by the BFI National Archive is something I'm incredibly excited about, and I'm so pleased that we're able to host this facility and build it within the Conservation Centre. The three main areas of research that MICRL will be a facility for: materials analysis, treatments and colour research. So materials analysis will mean that we can really examine non-destructively, so we won't have to be cutting even very small areas away from a film reel to determine something as fundamental as whether it's cellulose nitrate film, which is highly flammable, or safety film, for example. We'll be able to reveal its chemical composition and also tell something about its status, what condition it's in, by understanding its chemical composition. For example, we'll be using X-ray fluorescence, which can tell you about an element, a metallic element in objects, to look at silent film prints where they used a metallic toning agent, so the blue tone to represent a nighttime scene can often be discoloured now. So if you look at it, it might look green, but really it was iron blue toning, and this could be revealed by the X-ray fluorescence technique. Also, we noticed recently on the front cover of Derek Jarman's sketchbook for his film Blue, there's a gold patch. Is it paint or is it actual gold leaf? We'll be able to determine that with this kind of analysis. So that's what the materials analysis will reveal. I should add, there's a sort of safety element to this, because in the literature we know that some early colour films used uranium as the metallic element for toning, for bringing a kind of colour to the image. So we'd like to know about this before we go looking into those reels. The second item of research, or area of research, is treatments. What can we do with films that have undergone water damage or flooding, or maybe the opposite, maybe they're very dehydrated? What are sustainable and safe ways of cleaning, for example, film? And the third strand is colour research. We will still be digitising film, of course, in a very high level, and we want to be more and more authentic in how we do that. So we'll be looking at how we can model historical colour systems that were produced with very different media and represent them fairly, accurately, responsibly in digital cinema and on Blu-ray and other types of home entertainment. So this is a fascinating area, of course, and the BFI collections are stuffed with an incredible range of historical colour systems. But as a research organisation, this Riches programme with our Moving Image Conservation Research Lab is just part of what we've been able to invest in infrastructure for research. Recently, for example, we were awarded a significant grant from the Department of Science, Innovation and Technology to purchase infrastructure supporting film digitisation and understanding of the collections with machine learning. So that means we were able to invest in the laser graphics director scanner, which brings a new method of scanning films from 8mm to 65mm with the soundtrack as well. It's a very innovative system and piece of equipment, and it's supporting ongoing higher level film digitisation by the BFI National Archive. As part of that grant, we also have invested in a NVIDIA GPU, graphic processing unit, which means that we'll be able to carry out analysis of the collections of the film and video collections that have already been digitised in order to analyse them and understand them and make them even more open and accessible to all kinds of users. To take one example, we have a lot of video television that's been digitised, many thousands of hours, and using this server, which is incredibly efficient and can process at a very high rate, we'll be able to analyse the dialogue within those programs and turn it into text, which could then be analysed for the metadata, for the terms that relate to what the programs are about, what the content of the programs are. And this would be, in human cataloguing terms, very time consuming, several lifetimes. But this kind of infrastructure for research is really leading to some very exciting possibilities about making the collection even more open and accessible. Technical innovation has been at the heart of the BFI National Archive since it was formed 90 years ago. Our first preservation officer, one of the first in the world, was Harold Brown, a legendary figure in this area. He hand-built a film printer to print historical films when he was in the 1960s because there was nowhere else it could be done available to him. He made a wooden frame, he used Meccano, he used parts of a sewing machine, etc. And that sense of innovation being a necessary part of what we do, I think you can see as a thread through to our work now by my talented colleagues in the data preservation team to be the first archive in the world to preserve Netflix and Prime shows. You see it in the MICRL and in the other work around machine learning, as well as the preservation of historical technologies. There's no way around this, there can't be. We have to protect and innovate in technology in so many ways in order to care for and make accessible these collections.